Today we are going to study about this periodic table and its properties. Uh, the basics of periodic table. So there are many kinds of there are various types of elements in the earth. In the earth crust, these elements are found. Maybe in other planet, another different element can be added after this. So these are stacked or these are arranged in this type that the properties of chemical properties or the physical properties are nearly inheritance, means nearly if we can uh, show some improvisation or any it is show some little bit changes with changing with this period. These are like group types. So periodic table is arranged like these are the periods and these are the groups. So there are how many number of periods? You can see there are 7 number of periods. And there are 1, 2, 3, 4, 5, 6, 12, 17, 18 number of groups. And these two, which I have not counted in the period and group because this lanthanide to lutetium, this series is totally situation in this 57 to 71. And this actinide series, actinium to lawrencium, is situated here. So these lanthanide series are present in this period 6, and this actinide are presented in period 7. So these are arranged like this fashion, means going from hydrogen to lithium, lithium to sodium. They show some equivalent properties. That's why they are stacked in a group. But changing with this, the chemical or physical properties changes. But going from this to this in a single group, some physical or chemical properties inherit in these groups. So today we are going to study about this electronic configuration, how they are arranged, and what are their properties. So in periodic table, firstly, I'm going to so these are arranged like first you can consider it as a nucleus. Okay, nucleus. So according to Hund's rule or according to rules, there are various types of cell around this nucleus in which electrons are present, and these groups are named is like K, KLMN, or these are the principal quantum number which are arranged like 1, 2, 3, 4, or K, L, M, N. And these groups are also divided with subgroups according to the rule. So they are arranged like N equal to 1 means the first group, the K cell, contains S orbital. The N equal to 2, the L cell contains S and P. With increasing in N, the orbital number also increases. With N equal to 3, M it contains S, P, and D orbital. So these are arranged like this. Then what happens? So we got to know that orbitals, there are various suborbitals in orbitals, and there are like S, P, D, and F. Okay, and S orbitals having one. What it is called? Actually, I'm in confusion. D orbitals contain 3 cells. D orbital contain 5 cells. It is going with regards to adding one by one. Means two added with increasing with the cells, and F contains 7 number of cells there. And according to rule, only 2 electrons can be present in a cell. So in S orbital, only 2 electrons is present. In P, 2 in 3 cells. So there is 6. In D, 2 in 5 cells. So there will be 10 electrons. So in this period table, it is arranged like this rule. Means in H, the hydrogen, there is in hydrogen there are how many number of electrons in hydrogen? We can unmute and say, or there are
One.
1 electron is present in hydrogen. So this is the nucleus. In this cell or in this orbit, only 1 electron present. This orbit contains of S. You can say what is called SPDF. What we call SPDF as, or what is the nomenclature of SPDF? SPDF. N is cell or orbit, means number. N is contents of various numbers of L, means subcell. What we say the subcell, the other name of subcell, if you suggest any subcell, actually I forget. That's you can unmute and discuss with me. It's okay. So in hydrogen, there is only 1 electron, and it is arranged in like 1s1 because the 1 is the N. Okay.
Mm.
1 represents the N, S represents the L, means azimuthal quantum number, and this 1 represents the number of electrons present in this S. Okay.
Yeah.
So hydrogen contain 1. Then the helium contains 2 electrons, but and it is arranged like the arrangement is like I am talking about the arrangement. It is in the course of periodic table or not, I don't know. So a cell can contains only 2 electrons. Means a cell can contains 2 electrons. If electron goes to P cell, then there are 3 subcells in P, in which electron can arise in this fashion that no pairing occurred till every subcell got filled by half of the electron, means 1 electron. Then after all the subcell got filled, then the pairing will occur, because containing those 2 electrons in a single subcell, there will be repulsion between electron and electron. That's why in a single subcell, no 2 electron present till the vacant space is there. So after filling, then it can be paired. So in this manner, first thing in D cells, let me do in D cells. On firstly, all the subcell will be singly occupied. Then it will be paired. There are various exceptions also who will study in the midway, going through that. Now you can say and participate with me. The electronic configuration of various subcells. So we'll start from hydrogen. Okay. How it will be filled in 1:1 no. Then helium. There are 2 electrons, and the first orbit contains S, and S can contain 2 electrons. That's why it will be 1s2. The lithium, there are 3 electrons, means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are according to the atomic number. Atomic number always resembles the number of proton, not the number of electron. But to balance the neutrality, in neutral, this neutral metal or neutral atom, same number of proton and same number of electron is present. But always remember that the atomic number is always resembles the proton, not the electron. Okay. Because we can say that lithium plus, okay, still its atomic number is 3, but its proton electron count is not 3. Okay, electron count is 3 because it is a plus line. But the proton count will always be 3. Okay.
Mm.
So there will be 3 electron, and how it will be arranged, you can say with me how it will be arranged. Means the first 2 electron will go to the first cell. Okay. The second electron will go to the second cell. It will fill as like SPDF because A is having lower energy, P having higher energy, then D, then F. Okay, this will be the electronic configuration of Li. Then you can unmute yourself and can say what will be the beryllium one.
1:2, 2:2.
1:2, 2:2. Then the in this the S orbital got finished of the second cell. Then the boron, you can say
1:2, 2:2 to P1.
1:2, 2:2 to
To P1.
P1. Then carbon
1:2, 2:2 to P2.
then nitrogen.
To P3.
You can go with this pointer to P. Oxygen
To P4.
fluorine 5, then neon 6. Here what happens? The first period, which contains only the first cell, n equal to 1, means K cell. K cell contains only single S subcell, in which by hydrogen and helium, this subcell S got fully filled. Here in this second one, which one n equal to 1 and n equal to 2, these all those electron in this n equal to 2 also got filled here in neon. So what happened? In this series, all the cell got completely satisfied. So there is no need of this series, other need, no any other need. It doesn't need any other electron to get the to fill all those cells, or doesn't need to give one electron to fill the cell. That's why it is completely satisfied itself. So it is not reacting. That's why it is called as rare gas. Or as it is not reacting with any other, it will always stay in the atomic state. Means most of this time. Sometimes it reacts, but most of the time it stays in atomic state. Means only helium, only neon gas, not the neon 2, neon 3. That's like, okay. It is always in the atomic state.
Mm.
And these are mostly gaseous type till J radar. And as there are fully filled, so there is no interaction between this argon and argon. Means sometimes what happens in the sodium metal, let's sodium metal or let's the gold. Okay, what happens sometimes there are some vacant orbital there. Okay, in another gold metal also there are some vacant orbital, and there are some unpaired electron also through which these two atom metal can interact. Means these are not bonding, but some of the interaction occurred because of the presence of this vacant orbital. So that's why, because of this interaction, they can be solidified. Sometimes that gold you are wearing, that is in atomic state, only Au, not any salt state. Okay, that is in atomic state, but these are not in gaseous state because there are some vacant orbital through which one gold can interact with the nearby golds by some interactions, which we will study in future. So they can interact with each other. They can form a band. They can form a molecular orbital because of this interaction. That's why they can be solidified. Means they are solid. But here, still, as the atomic number increases, still because there are no vacant electrons, so no interaction occurred between the neighboring. Means the argon doesn't react that much with the argon. So that's why it is in the gaseous state. I think we need to delete some of the space here. Okay. Still, okay, we can continue with the electronic configuration then. We have reached till neon. Then what will happen in sodium in the 3-1? What is the atomic number of this? You can see from here there is 11. Okay, so 11 number of what? Atomic number 11 means what? No, what is the means proton number 11 or electron number 11 or nucleus neutron number 11? Atomic number 11 means
Nucleus.
no, means the proton number is 11. Okay, P equal to 11. Okay, so the E equal to 11 because of this to maintain the neutrality, electron equal to 11. And what will be the configuration of the sodium? You can start from the starting one. 1s2.
2s2.
Then
2p6.
2s2, 2p6, then
3s1.
PS1. And sometimes another nomenclature also followed. This 1s2, 2s2, 2p6 is matching with neon, no? So sometimes these type are written neon, then 3s1. Okay.
Okay.
So you can say from this, then magnesium, what is the electronic configuration? You can say like this.
3s2. Neon 3s2.
Then aluminum,
Neon 3s2. 3p1.
3p1. Then 3p2, 3p3, 3p4, 3p5, 3p6. Okay. Here, a thing comes. Three contents of S, P, and D. Yes or not?
Yes.
But here in this, in this position, P means the cell is filled, but the D is not filled. And again, we are starting from the 4s1, from the potassium. Okay. Why this is happened? Do you have any answer?
No.
Because there is a rule. Without filling the D, the next orbital S got filled. This is according to the n plus S rule. Okay. Okay. The period is the n.
Okay.
Means the orbital in which it is filling is the n. Okay, 3 orbital. Then L is the subcell number, S, P, D, F. S, P, D, and F. Okay, and it is named like 0, 1, 2, 3. 0, 1, 2, 3 or 1, 2, 3, 4. Hello? 0, 1, 2, 3 or
0
1, 2,
and
3. Okay, 0, 1, 2, 3.
1, 1, 2, 3 बोले 0 का?
You can check and say what is the value of L.
Oh, L 0. Yes, yes. Right.
0, 0, 1, 2, 3,
L
no?
0. Then it says 0 and 2, 3.
Okay. What is the value of here? The 4s1. Okay. 4s1 versus 3d1, because we have not let the electron go to 3d1 but the 4s1. Okay. The next electron. So there will be a competition between 4s1 and 3d1. Okay. Because in this 3s1, 3s2, 51 will occur till argon. Then atomic number 19, the electron will go to 4s1, not the 3d1. As there is 3d1 is still vacant of the third cell. You got it or not? The electron goes to 4s1, not the 3d1. Why? We need to check here. What is the n plus L value of 4s1? 4s. 4 is the n,
4. 4.
s is the L. Okay, n plus 1 is 4. Then the 3d1,
5.
3 plus spd 5 here. 5. So what the energy of 3d is higher than the energy of 4s.
Chorus.
So the electron always feel in the lowest energy orbital because more energy required for the 3d1. Okay. I am erasing all those. Okay. Here one concept is clear. The n plus L rule you got to know. Then the you got to know now why their electron doesn't go to the 3d1 but the 4s1. As
Yes. Good.
the we can write it like argon. We have already discussed it. Argon 4s1 is the potassium. Okay. Then calcium. What will be the electronic configuration? Hello.
1s2, 2s2,
You can say like
6.
argon, then
Okay,
4s1,
argon.
then 4s2. Argon
Argon.
4s2 will be the calcium.
Argon 4s2.
You can then here it comes another one. After 4s, you thought that electron will go to 4p1. Yes or no?
Yes.
But this contains S. Always remember this contains S. This from this to this of D, and from this to this of P of the periodic table. Okay. These are F. So SPDF. So you don't need to remember what is the electronic configuration, how the electronic configuration. If the atomic number is 26, what will be the electron configuration? How I will arrange the electron configuration. So you only remember this periodic table. No need to remember those electronic configuration because 1 is to S, 1, then 2, 2 is to P, then 3, 3 is 3P. But in the 3, there is no D in the periodic table. So you just omit D. Then 4S, Then the D come, which will be of 3. 3D, then 4P, because it is of the 4 periodic table. Then 5S, 4D, 4P. 6S, 4F, 5D, 6P. These are some technique. So anything in the periodic table, you no need of remembering any electronic configuration. This is a shortcut. You just remember this periodic table. Someone asked, what is the electronic configuration of this iridium? Suddenly, you don't need no need of remembering any atomic number or anything. You just go remember this periodic table. You can write all those 1s, 1s2, 2s1, 2s2 to p, this all. Or another thing, you just write the electronic configuration of xenon because it is above in the periodic table. Then this is the 6th period. 6 S2 finished. Then before iridium, this red color F cell is coming. Then 4F14 is finished. Then it is coming of the before 5-1. Then 5D 1, 1, 2, 3, 4, 5, 6, 7. 5D7 will be the electronic configuration of this iridium. We have not go through any of the atomic number. We have not go through any of the technique. But by remembering the periodic table, we can write the electronic configuration. Okay.
6
Any
plus
doubts?
7 minutes. 56.
Because this one is the D1,
Okay.
not D0, because it is in the D. Okay.
Okay.
So I have mentioned the atomic number of 77 here. I have not mentioned, no, but I can write the electronic configuration by only remembering the periodic table. Periodic table is have great power in chemistry. Okay. So we have reached the electronic configuration till potassium. Okay, it is like argon 4s1, 4s2. Okay, of the calcium. What will be the electronic configuration of scandium? Here the doubt arises. Why the electron is not going to 4p1 but goes to 3d1? So here you can check the n plus n value. What is the n plus l value of 3d? This is n.
5.
This is d. This is 5. And what is the n plus l value of 4p?
5.
4p 5. Here comes another. If the n plus l value is same of 2 orbital, then we always go through the n value. N value having lower, the electron will go there. Okay.
Okay.
So here the electron goes to 3d1. Then the titanium, you can continue speedily. (3d2, 3d3, 3d4, 3d5). Then it will means the electronic configuration you can write. Okay, I am writing the box structure. Okay, this is scandium, 1 electron, titanium. It is not pairing because of these rules. Repulse unilarize. Vanadium, chromium, manganese. Here the D5 also is fully half filled. Then the pairing is occurred. Okay. Till zinc, 3d10. Am I right?
Yes.
Then sp(d), 3 orbital now fully occupied. 4s is now occupied. Then the possible is 4p. Now from gallium to krypton, 4p1, 4p2, 4p3, 4p4, 4p5, 4p6. Okay, am I correct?
Yes.
Then the electronic configuration. Then 4 having 4d and 4f, because n value is 4, no? So 4 subcell will be present. If n value is 5 or 6, what will be the subcell number? You can give a hint. S, P, there will be 6 subcell. What will be the name? SP?
D,
Go on. D, then
F, don't know.
GHI. Okay. If in
Okay.
near future, if more number of elements, if we found in the air crust or in sea level, if more number of electron or element we found, if we found, then it will be added. If someone react this element by nucleophilic reaction, means not nucleophilic, nuclear reactions, some proton bombardment or some electron bombardment, is some of the new element formed, then it will be added, and this number is electron configuration is like this, GSI. Okay.
Okay.
Still, people are doing research in this new number of elements. They are synthesizing or they are creating. They are naming like this. Then we are reached till this one gallium. Here comes another where we have filled till 4p. There is left 4d and 4f. Okay. But the next electron of the next atomic number having 37 atomic number, the electron goes to 5s1, not the 4d and 4f. We can say it by n plus n rule, but it's the 4d n plus l versus 5s n plus l. Okay, give me the answer. 4d n plus l.
For D is 6.
5s,
For F, 7.
5s.
5.
S is 0 now.
5 is 5. 5.
So which wins? 5s.
5.
4f means 7. 4f means 7. So 5s clearly wins here. So the electron will go to where? 4d or 5s? 5s. So the electronic configuration of these are krypton 5s 1, 5s 2. Here comes versus 5p versus 4d, because 4d and 4f were left in the 4 cell. 4p n plus l value is 0, 1, 1 plus 5 equal to 6. 4d 4 plus 2,
6.
6. Both having same means what is the rule? Having lesser n.
For D.
4d. So here comes 4d 1, 4d2, 4d. Then after 4d, the electron should go to 4f, because 4f is still left vacant. Okay. But the electron is going to 4p. Why? Sorry, 5p. 5p versus 4f. N plus L value.
5P is 7.
Why 7? P is 1, no? 0, 1, 2,
Sorry,
SPD.
6.
4f.
7.
7. Which clearly wins? 5p, no?
5P.
So these are like 5p1, 5p2, 5p3, 5p4, 5p5, 5p6. Okay.
Okay.
Just you don't need to remember the atomic number of the molecule. Only the periodic table you remember. Give its atomic number. Any electronic configuration go from this previous noble gas configuration. And with P, this period number 5s, then the previous D, then the going on 5p. Okay, these are the themes. So in future, maybe you can able to write the electronic configuration without knowing or without remembering much. Then the 5p got filled, then the 6s come. Still in 5, the D is left, F is left, E is left of this 5. SPDF, G, sorry, G is left, not E. G is left. Okay. But without filling this, the 6 is filling because of this N plus L rule. But here, the 6p versus the 5d, 5d also left versus 4f. The 4f clearly wins because of this lower number of N. Okay. Then,
Okay.
then these elements are means kept the other position from the periodic table, the outward position. Why do we know? Why it is not written along with this after lanthanide in this?
No,
Then
we
the
haven't.
then periodic table will be too large. There will be a gap after this. For easy understanding or easy writing, these are having different properties. So that's why for easy remembering things, for doing all those things easily, they have just kept it behind. Because there will be a gap here, then the 4f will start. A gap will increase from this 6 one, and it will be looks so odd. Okay. So F comes. I think you can write the periodic table now. Only from viewing the periodic table, you can write the electron configuration. I am randomly asking something. Okay. You just remember this is a 4f, this is a 5f. Okay.
Okay.
And this D here, you just remember this is 4f, this is 5f. And this D means the D, though it is starting from period 4, but the D are like 3, 4, 5, and 6. Okay. Though it is starting from 4, 1, 2, 3, 4, potassium. But these are 3, 4, 5, 6. Means from 4, 3 is started, 5, 4, N plus 1. Okay, the DR. Suddenly I am asking the electronic configuration of this CN. I don't know the name. Just see the periodic table and say me the electronic configuration. You can, huh? What I will write? Suggest me.
Then,
Radon.
then
Okay, radon.
radon.
Then going to the 7. Okay. 7s2 will fill. 7s1, 7s2. Then this one is of actinide of green color, means 4f. Yes or no? 5f, green color. 5f, 14, because f can contain 14 electrons. Then this one, n minus 1, 7 minus 1, 6. D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. This one will be 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. By only remembering the periodic table, you can write every electronic configuration. Okay or not? Here I'm pausing this for some time. Mm,